According to the National Electrical Code, a general-purpose branch circuit is allowed to be loaded to a maximum of 80% of its amperage rating. It's important to understand what constitutes a continuous load and how it affects circuit sizing. A continuous load is defined as a load that operates for 3 hours or more. Lighting is not typically considered a continuous load. When sizing a branch circuit for a continuous load, the overcurrent protection device and the conductors must be rated for not less than 125% of the continuous load. This 125% factor is the reciprocal of 80%. The National Electrical Code allows you to use the actual load current when sizing the circuit for non-continuous loads. To determine the actual load current, we use Ohm's law. Ohm's law states that power equals voltage times current. The formula can be rearranged to solve for current, where current equals power divided by voltage. To calculate the current draw, divide the total wattage by the voltage. In a 120-volt system, if the total wattage is 2175 watts, the current is calculated as 2175 watts divided by 120 volts, which equals 18.13 amps. The circuit is adequately sized if the actual load current is less than the circuit's amperage rating. For example, on a 20 amp circuit, the maximum load should not exceed 20 amps. It is important to consult the National Electrical Code and local electrical codes for specific requirements and regulations in your area. Electrical codes may vary depending on the jurisdiction. Always follow safety precautions when working with electricity. Always de-energize the circuit before working on electrical components. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to perform electrical work, hire a licensed electrician. Using the example of a 20 amp circuit at 120 volts, we can examine the calculations for both continuous and non-continuous loads. For a continuous load, the maximum load is limited to 80% of the circuit breaker's rating. To determine the maximum continuous load in watts, we first find the amperage limit, which is 20 amps multiplied by 0.80, resulting in 16 amps. Then we multiply this amperage by the voltage, 120 volts, to get the maximum continuous wattage, which is 1920 watts. However, for non-continuous loads, the full 20 amp capacity of the circuit can be utilized. In this case, the maximum wattage is simply the product of the circuit's amperage and voltage. Therefore, the maximum non-continuous load in watts is 20 amps multiplied by 120 volts, resulting in 2400 watts. The National Electrical Code provides tables and guidelines for conductor ampacity, which is the maximum current a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The ampacity of conductors depends on factors such as the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. When selecting conductors for a branch circuit, it is essential to choose conductors with an ampacity rating equal to or greater than the circuit's overcurrent protection device, such as a circuit breaker. The National Electrical Code Section 310.13 contains detailed information on conductor ampacity and ampacity adjustment factors. In addition to conductor ampacity, voltage drop is another important consideration when sizing branch circuits. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and other electrical equipment to malfunction. The National Electrical Code recommends limiting voltage drop on branch circuits to no more than 3% for lighting, heating, and power loads, or 5% for feeders plus branch circuits. To minimize voltage drop, it is important to use conductors of adequate size and to keep circuit lengths as short as possible. The National Electrical Code provides formulas and tables for calculating voltage drop. Grounding is another critical aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and de-energize the circuit in the event of a ground fault. The National Electrical Code requires all electrical equipment and systems to be properly grounded. Grounding conductors must be sized according to the National Electrical Code Table 250.122, based on the size of the overcurrent protection device. Grounding electrodes, such as ground rods or ground plates, must be installed to provide a connection to earth. The National Electrical Code Article 250 contains detailed requirements for grounding and bonding. Arc fault circuit interrupters are devices that are designed to protect against arc faults, which are dangerous electrical faults that can cause fires. Arc faults can occur when there is a break or weakening in the insulation of a wire, or when there is a loose connection. The National Electrical Code requires arc fault circuit interrupter protection for branch circuits that supply outlets in dwelling unit bedrooms, living rooms, dining rooms, family rooms, recreation rooms, libraries, dens, sunrooms, and similar areas. The National Electrical Code Section 210.12 contains detailed requirements for arc fault circuit interrupter protection. Ground fault circuit interrupters are devices that are designed to protect against ground faults, which are electrical faults that occur when current flows to ground through an unintended path. Ground fault circuit interrupters are required for outlets in wet locations, such as bathrooms, kitchens, and outdoor areas. The National Electrical Code Section 210.8 contains detailed requirements for ground fault circuit interrupter protection. Electrical boxes are enclosures that are used to house electrical connections such as splices, terminations, and devices. Electrical boxes must be sized according to the National Electrical Code Article 314 based on the number and size of conductors and devices in the box. Electrical boxes must be securely mounted and accessible. Conduit is a type of raceway that is used to protect and route electrical conductors. Conduit can be made of metal, plastic, or fiberglass. The National Electrical Code Article 342 through 356 contains detailed requirements for conduit installation. Wiring methods refer to the different ways that electrical conductors can be installed. The National Electrical Code recognizes a variety of wiring methods, including non-metallic sheet cable, armored cable, metal-clad cable, and conduit. Each wiring method has its own advantages and disadvantages, and the choice of wiring method depends on the specific application. The National Electrical Code Chapter 3 contains detailed requirements for wiring methods. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overcurrent protection devices must be sized according to the National Electrical Code Article 240, based on the ampacity of the conductors being protected. Circuit breakers and fuses must be properly labeled to indicate their amperage rating. Electrical panels are enclosures that house circuit breakers or fuses, and provide a central location for distributing electricity throughout a building. The electrical panels must be sized according to the National Electrical Code Article 408, based on the total load of the circuits being served. Electrical panels must be properly grounded and labeled. Electrical safety is paramount when working with electrical systems. Always to energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to perform electrical work, hire a licensed electrician. The National Electrical Code is a comprehensive set of standards for electrical installations. It is important to consult the National Electrical Code and local electrical codes for specific requirements and regulations in your area. The National Fire Protection Association publishes the National Electrical Code. Understanding the principles of electrical circuit sizing and loading is crucial for ensuring safe and efficient electrical installations. Always prioritize safety and consult with qualified professionals when necessary. Remember to consider all applicable codes and regulations. In summary, when dealing with a 20 amp circuit, understanding the distinction between continuous and non-continuous loads is key. For continuous loads, the maximum allowable load is 16 amps, or 1920 watts at 120 volts. For non-continuous loads, the full 20 amp capacity can be used, allowing for a maximum load of 2400 watts at 120 volts. Always refer to the National Electrical Code for specific requirements and ensure compliance with all applicable regulations.